Okay, let's consider an example of Gauss-Seidel method. First, let's consider an example. I will be giving equations, three equations for three variables. 10x1 minus x sub 2 plus 2x sub 3 is equals to 6. Negative x sub 1 plus 12x sub 2 plus 4x sub 3 is equals to 24. And 2x sub 1 minus 2x sub 2 plus 10x sub 3 is equal to 11. The second thing we will do is we will test if these equations are diagonally dominant by the converge method. So, 10, the first equation should be 10 is greater than to the two variables. 10 is greater than 1 plus 2. 12 should be greater than x sub 1, which is 1, plus x sub 3, which is 4. So it's correct also. Then for the last equation, 10 should be greater than also to 2 plus 2. And it's correct. So, sige. So these equations are diagonally dominant. The third thing we will do is we will solve for x1, x sub 2, and x sub 3. How? X sub 1 is equal to 10. We will transpose this to the other side, plus x sub 2 minus 2x sub 1 is equal to 6, plus x sub 2 minus 2x sub 3 all over 10. For x sub 2, 2 equals 24, plus x sub 1 minus 4x sub 3 all over 12. For x sub 3 equals 11 minus 2x sub 1 plus 2x sub 2 all over 10. For the iteration part, we will solve that using the initial guesses of 0, 0, 0. But we will for the iteration part, we will solve that using initial guesses of 0, 0, 0. But first, we got the true values, which are 302 over 609, 325 over 203, and 1609 over 1218. And we will start the iteration. Number 1. I will be doing iterations only three iterations. First, x sub 1 is equal to 6 plus x sub 2 is equal to 0 minus 2 times x sub 3, which is equal to 0 also, over 10. X sub 1 is equal to, I don't know the answer, we will solve. C over 5. Pero sunod ko na lahat. Ay, narinig. For x sub 2, 24 plus the present x sub 1, which is 3 over 5, minus 4 times 0 all over 12. 24 plus 3 over 5 minus 0 over 12. 41 over 20. And for the x sub 3, 11 minus 2x sub 1 plus 2x sub 2 over 10, or equal to 11 minus 2 times 3 over 5 plus 2 times 41 over 20 over 10. 11 minus 2 over 3 over 5 plus 2 over 41 over 20 all over 10 equals to equal to x3 is equal to 139 over 100. And for the percentage error, EA1, EA2, EA3, for the percentage errors, all of those are 100%. Why?
Why?
Because we have initial guesses of 0, 0, 0.
Oh, I see.
Okay. Equation number 2, we use the same equations for x sub 1, x sub 2, and x sub 3, and we substitute the present values we obtained from the previous iteration, which is 3 over 5, 41 over 20, and 139 over 100. As we substituted all of that values using the same equations, the value for x sub 1 is 527 over 1000. X sub 2 is 1.5809, and x sub 3 is equal to 1.31078. And for the percentage errors, we use the formula for minus past over present value times 100%, and we get 13.85% for EA sub 1, for EA sub 2, 29.67, and for EA sub 3, 5.78%. And for the iteration number 3, using the same equation, and we substitute again the values we obtained from the iteration number 2. So the present values are 527 over 1000, 1.58 of 5809, and 1.31078. And for the x sub 1, as we substituted the values, we get 0.496, and x sub 2 is equal to 1.6044, and x sub 3 is equal to 1.32168. And for the percentage values, EA sub 1 is equal to 6.25%, EA sub 2 equals 1.46%, and EA sub 3 is equal to 0.8247%.
3.
As we have noticed, the more iterations we have done, the more applicable ito. As we have noticed, as we do more iterations, we are getting closer to the true value, which are 0.4959, or in iteration number 3, so close. And again, 1.60099, 1.6044. Then for the last true value, 1.32101, and we get here 1.32168.